In this video, we are going to do a brief introduction to equations. An equation is a mathematical sentence that uses an equal sign. So with equations, we are able to solve and find out what the variable is equal to if that equation is algebraic. There are three types of equations: true, false, or open. A true equation is an equation where each expression on the left and right of that equation are equal to each other. One example of that would be 24 plus 18 equals 20 plus 22, because both sides of that equation have a value of 42. That is a true equation because 42 does equal 42. A false equation is when one side of the equation does not have the same value as the other. So for example, 7 times 8 equal to 54. That is a false equation because 7 times 8 is 56, and 56 does not equal 54. They are not the same values. And lastly, an open equation is when there is a variable included in the equation. It's open because we are not sure exactly what that variable will be equal to, so we cannot clearly state if it is true or false. In order to decide if an equation is true or false or open, to determine between true or false, we need to find out the values of both the left and right hand sides. So looking at this first example, 6 plus negative 2 is 4. 4 is not the same value as 8, so this equation is false. In the second example, there is a variable included, so we do not have enough information to determine if the equation is true or false, so we state that it is open. In the last example, 15 minus 20 has a value of negative 5, which matches the value on the right side of the equation, so we would state that this equation is true. Included in the open equations are solutions. We are able to find a solution to that equation, and we can also determine if a given possible answer is a solution by plugging that variable in and seeing if it makes the equation true. So I'm going to take this variable value of 2 and plug it in for x into my equation. In this equation, x is getting multiplied by 2 and then adding 5 to that product. So I'm going to follow PEMDAS and do my multiplication before my addition. And after I simplify this equation on both sides, I find that the values are the same on both the left and the right hand sides. So yes, this is a solution. In this next example, 1/2 is my possible solution. I will not follow any different steps just because my possible solution is a fraction. I'm still going to plug that in. M is getting multiplied by 10, so I'm going to multiply 10 times 1/2, then subtract 6 from it and see if I get a value that is equal to negative 1. 10 times 1/2 is the same thing as 10 divided by 2, which is in fact 5. Then I can simplify by doing my subtraction, and 5 minus 6 is negative 1. So yes, this is a solution because it creates a true equation, the same value on the left as the right hand side of the equation. In this last example, we're going to determine if negative 3 is a solution to this equation. So we're going to multiply it by 4 and then add 2 to it. Once again, following PEMDAS, in order of operations, I need to do the multiplication before I do the addition. Negative 12 plus 2 is negative 10. That is not a true statement. This is a false equation, so no, this is not a solution. It is not a solution to this equation because it created a false equation. The value on the left is not equal to the value on the right. We can also determine if ordered pairs are solutions to equations that include an x and a y. The biggest thing to remember with these are that every ordered pair follows the form of x comma y. So I'm going to take this first term, which is my x value, and plug it in for x, and the second term, 12, and plug it in for y. I'm going to follow the same steps. I'm going to plug in now just for 2 variables rather than 1, and then I'm going to follow PEMDAS and see if I have a true equation. I do have the same value on the left as I do on the right, So yes, this is a solution to that equation. In the next example, I have a y value of positive 6 and an x value of negative 1. In this equation, x and y, there's no operation being done to them, so I can just copy them straight down into my equation. And the only math I need to do is that sum of negative 1 plus 5, which is 4. This is not a true equation, it is false, so no, negative 1 comma 6 is not a solution to the equation.